Dear students, welcome back to the second semester BSc Physics class. In this session, we shall discuss about the Fourier series and the evaluation of Fourier coefficients. In the previous session, we have discussed about the Fourier series. What are the uses of Fourier series in the analysis of complex wave? How the Fourier series was invented, and what are the Fourier coefficients? Fourier theorem can be expressed in the form of a series as y is equal to f of t is equal to a naught plus a1 sin omega t plus a2 sin 2 omega t plus a3 sin 3 omega t, etc. up to infinity, plus b1 cos omega t plus b2 cos 2 omega t plus b3 cos 3 omega t plus etc. So this is the Fourier series, or the mathematical representation of the Fourier theorem, where the sine functions and cosine functions are summed up in a series. In general, the Fourier series can be expressed in the summation form as y is equal to f of t, where it is a function of time, that is equal to a naught plus summation n is equal to 1 to infinity of an sin n omega t plus summation n is equal to 1 to infinity of bn cos n omega t. Let this be equation number 1, and in this equation we find a naught, an and bn as the Fourier coefficients in the Fourier series. Now we can evaluate these Fourier coefficients, and we can get expressions for different Fourier coefficients. Now let us consider the evaluation of Fourier coefficient a naught. To find a naught, we have to integrate on both sides of equation 1. So this is the equation number 1. So integrate this equation on both sides within the limits time t is equal to 0 to time t is equal to t. So where t is the periodic time, which is given by 2 pi by omega. So now integrating, we get like this: integration of f of t with respect to t within the limit 0 to t is equal to integration of a naught into dt from 0 to t. This is the integration of the first term in the equation 1, and this is the second term, and this is the third term of the integration of the equation 1. Now using the standard integrals, we have some standard integrals. By using these, we can minimize the steps in the simplification process. The standard integral, integration of sin n omega t with respect to t between the limit 0 to t, will give us 0 always. Similarly, integration of cos n omega t with respect to t within the limit 0 to t is also 0. Using these standard integrals, we get the integration of equation 1 will be 0 to t, integration 0 to t of f of t dt, that is equal to a naught into t plus 0 plus 0. So the integration of the sine term will be 0, and integration of the cos term will be 0. Therefore, equation 1 becomes, in terms of a naught, we can write a naught is equal to 1 by t into integration of f of t dt from 0 to t. So this gives the equation or the expression for the Fourier coefficient a naught. Similarly, we can evaluate for the Fourier coefficient an. To find an, we have to multiply the same equation number 1 on both sides by sin m omega t. The term sin m omega t should be multiplied and then integrated. So where m is any integer, integrating between the limits time t is equal to 0 and t, so we get equation 1 becomes like this: integration of f of t sin m omega t dt between the limit 0 to t, that is equal to integration between the limit 0 to t of a naught plus summation n is equal to 1 to infinity of an sin n omega t plus bn cos n omega t into sin m omega t dt. So this is multiplied. So after multiplication and integration, so it is written as like this: integration a naught into integration of sin m omega t dt plus summation n is equal to 1 to infinity of an into integration of sin n omega t into sin m omega t dt between the limit 0 to t plus another term summation n is equal to 1 to infinity of bn into integration of cos n omega t into sin m omega t dt between the limit 0 to t. After integration and using the standard integrals, here these are the standard integrals. So here the second standard integral, we use integration of sin n omega t into sin m omega t dt within the limit 0 to t will give us 0 for n not equal to m, and the same integration gives t by 2 for n is equal to m. By using these standard integrals, and here another standard integral is there, that is integration between the limit 0 to t cos n omega t into sin m omega t dt is equal to 0 for n is equal to m as well as n not equal to m. Using these standard integrals substitution, we will finally arrive at the final expression for the Fourier coefficient an is equal to 2 by t into integration of f of t sin n omega t with respect to t between the limit 0 to t. So this is the expression for the Fourier coefficient a naught. Now let us discuss about the evaluation of the Fourier coefficient bn in a similar way. To find bn, multiply equation 1. If we multiply equation 1 on both sides by cos m omega t and integrating from t is equal to 0 to t is equal to t, we will get integration of f of t cos m omega t dt is equal to integration of a naught plus summation n is equal to 1 to infinity of an sin n omega t plus bn cos n omega t into cos m omega t. So here we have to multiply the term cos m omega t to the expression 1. So therefore, after simplification in different steps and using the standard integrals like this, so these are the standard integrals we can use in the simplification, and we will get the expression for the Fourier coefficient b naught is equal to 2 by t into integration of f of t cos n omega t with respect to t within the limits 0 to t. So this is the expression for the Fourier coefficient bn. Hence, in this session we have discussed about the Fourier series, the theorem, Fourier theorem, and evaluation of the Fourier coefficients such as A0, An and Bn. Thank you.